We're deeply grateful to our exceptional leaders, our speakers, and panelists who will share their expertise, practical advice, and inspiration throughout the week. AI, or artificial intelligence, is a significant theme at this conference this year, reflecting future of work trends, emerging skills, and opportunities. We're so excited about this next talk and fireside chat. Professor Arvind Narayanan, faculty and professor of computer science and director of Center for Information Technology Policy, or CITP, and co-author of the book AI Snakeoil that a lot of you have in your hands right now, will give an overview talk and have a discussion with the graduate school dean, Rod Priestley, and they will examine the critical question of does AI help or harm creativity in research, and discuss AI's impact on the next generation of scholarly research and academic innovation. Following the fireside chat, we will have an open Q&A section with our audience. We'll run around with mics for you, so bring all of your curiosity to the fore and ask as many questions as you want. But first, please join me in welcoming Professor Arvind Narayanan.
Thank you, Sonali, for that kind introduction. Hello, everyone. It's great to be here. I want to start off with a brief talk just laying out the way I think about this topic. And I'm going to be provocative, not just for the sake of being provocative, because it's what I believe. I do believe we're in a moment of crisis, but that's something good potentially can come out of this crisis. But I think the real fun part of today is the chat with Professor Priestley and with all of you. So I look forward to that. Now, the question of will AI help or harm research creativity is a very polarized one. There are some people who predict a kind of utopia. This is Dario Amodei, for instance, CEO of Anthropic, who envisions a quote-unquote country of geniuses in a data center, with innovation happening on dramatically accelerated timescales. There are also many skeptics out there who worry that AI is already generating so much slop and bullshit, and that this is pervading the scientific literature and discourse, and that this is only going to accelerate in the future. So which of these, how should we think about this? I think to make sense of this, we have to be more specific about what we mean by AI in research. So specifically, if we talk about science, for instance, there are so many different ways to use AI. I don't want to go through all of these in detail. I will talk about several of them. But the point here is that you can imagine a spectrum between, at the bottom, using AI to process scientific data, which is something we've done for a very long time, with types of automation that we necessarily weren't calling AI before, versus using AI to process scientific ideas in some way. And that's what's really new. So the things at the bottom could have been done with traditional machine learning, have been done for a very long time. I'll say a little bit more about those. But the concept that you can now use AI to, for instance, generate new ideas or hypotheses, that has only become possible in the last couple of years, and that is really what is leading to a lot of excitement. The key thing I want to give you is that while there is a lot of talk about what AI might enable in the future, there already is a lot of low-hanging fruit. There are already many productive ways in which researchers are using AI to enhance creativity or research or scientific ideas in some way. And I want to share with you what some of those are. But the theme is going to be that none of these kind of comes for free. All of them come with risks. All of them come with the risk of pitfalls or de-skilling, which is what happens when we start relying on this and we lose our own abilities of scientific inquiry. And I want to say that our focus really should be on thinking about how do we integrate these existing AI capabilities in a responsible way into our scientific workflows. And that should take precedence over dreaming about what AI might be able to do in the future. And even this task of integrating current AI capabilities, I want to claim, is going to be very, very difficult. And I will give you some sense of why I think that is and what we can do about it. Okay, so I want to give you maybe 5 examples of what I mean by low-hanging fruit. And one big area in which so almost all the things I'm going to talk about are things that me or my research group are already doing in our own research. So this is not, reflecting other people's visions, which, you might wonder, is this hype or is this something that I really believe in? So I'm only really mainly going to tell you about the things that I believe in because we're already using it. So one big area is coding and data visualization. Some of you might be familiar with the idea that what you can do today is to simply upload a spreadsheet or a CSV file or some other data file into a chatbot and just ask it to visualize the data, do some basic data analysis, or create a machine learning model on the spot and use that model to analyze the data. Uh, if uh, if you haven't seen capabilities like this, I very much encourage you to look it up. This is real. It's very powerful. There are risks. I'll talk about the risks in a second. But this is, in fact, something remarkable that has become possible in the last couple of years. And this example is the IRIS dataset. It's a famous dataset used for machine learning research. It's a small dataset of about 100 rows. It's visualized into 3 clusters in this example, but you can use these kinds of techniques to automatically analyze much larger and more complex data sets. The risk, of course, is that when AI is writing code behind the scenes to produce this graph, that code might have bugs, and so the resulting analysis might be flawed. And of course, there are ways to mitigate that risk. So you can think about, for instance, if you divide research into an exploratory phase and a confirmatory phase, as it often is, to only use AI for this kind of purpose in the exploratory phase, so that everything that happens in the confirmatory phase is code written by the researcher, so you're not subject to this risk so much. And that's easy to say, but putting that into practice, I think, will require changes to workflows and training that is going to be a rather slow and painful process. Another example of low-hanging fruit is data cleaning. I apologize if that's not so visible, but what you see on the screen there is just for this toy example, I've created 10 addresses that have various kinds of problems with them. Some of them are missing zip codes, some of them are misspelled, some of them the state might be deliberately wrong, etc. And if you think about data cleaning is a very big part of science, you need your data to be correct in order to be able to process it correctly. And if you were to manually write a whole bunch of heuristics in order to clean the data, that would be a very painful, very time-consuming process. And this is something that today's generative AI models can do because they have some version of common sense. So data cleaning is something that I use AI very often for. Similarly, data scraping and automatically gathering data from online sources. There have been a bunch of new products that have been released that enable web scraping in a much easier and more powerful fashion than was possible before. And of course, there's a risk of errors there. And of course, again, there are mitigation steps. You can imagine that you only do this if you're willing to manually check a sample of the data and verify that the error rate is low. Okay, third example of potential low-hanging fruit, and this is from some research that we've done recently. This is on the notion of computational reproducibility. So computational reproducibility is the idea that if you want to build on someone else's research, the first thing you have to do, almost goes without saying, is to download their code and data and to rerun that code and data and see if it produces the same results, the same figures that have been reported in the paper. So very often, this turns out to be a laborious, time-consuming process that might take hours or perhaps days, and you might not get the same results that are reported in the paper. There might be bugs in the code, or it could be something subtle like your computer has a version of a software library that is different from what the authors use, and it turns out that the code is so sensitive to those differences that it actually produces a different result. So computational reproducibility is actually a kind of mundane and boring thing that we all have to do as researchers, and it turns out to be one of those sticking points, one of those pain points that inhibits the smooth functioning of the processes, such as reproducibility, that we need for science to be healthy. So we think this is close to being automatable. So we've taken the first steps in this respect, and we're working with some folks to see how practical this technology is in order to automate the process of downloading code and data and running that code and seeing if you get the same results that are reported in the paper. Related to reproducibility is error checking. So this is, assuming there are no flaws in the paper and the code, can you reproduce it? But what if there are flaws? Can you catch those flaws? So that's error checking, and this has taken off recently as an area of interest for a lot of people. The way this happened is there was a paper that reported, I think the paper was in Science or Nature, one of those journals that got it a lot of media attention, that claimed that if you cook with a black spatula, it's going to release, I think, if I remember correctly, volatile organic compounds that are much more dangerous than other colors of utensils. And you can imagine how that would get a lot of people's attention. There was a lot of attention to this paper, and then someone realized that the claims they had made were based on some arithmetic calculations that actually had an error. An extra zero was added, and so the effects in reality were 1/10 of what was claimed in the paper. And that was, of course, very embarrassing for all concerned. But the real kicker was that you can take the text of the paper, just dump it into ChatGPT, and ask it to see if there are any errors, and it will immediately spot the error, it turns out. And so that was the origin of the Black Spatula Project. So if it is possible that there are errors lurking in the scientific literature that AI could perhaps automatically catch, can we do that at scale? And so there have been a couple of different efforts to start doing this in a more systematic manner. There are definitely very serious risks here. So you can imagine a spate of false accusations because of this. Again, there are ways to mitigate them. One, perhaps, bright line can be that you as a researcher should only make this accusation because you take responsibility for the consequences of that, not just saying that AI claimed this is wrong. AI spotted a potential error. I have verified it, and I think your paper is wrong. So that I think should be the contract in this kind of process. Okay, fourth example of low-hanging fruit. This is one that I very much, again, use all the time, and this is semantic search. So semantic search, I apologize, there's a lot of text here. Let me explain what's going on. So in this instance, I wanted to look for case studies of AI deployment by various government agencies. It could be, the IRS, or it could be the Department of Justice, and so on and so forth. So how would I go about it? So before AI-based search engines, there's a couple of ways I could have done it. I could have generated a list of 50 different government agencies and searched for AI case studies in each one of them. Or I could have just put in case studies of AI deployment in government agencies. And traditional search engines are still largely keyword-based, even though they have been trying to incorporate smarter ways of searching. That's not working so well, but newer AI-based search engines can, in fact, understand the query better and can come up with a case study involving the Office of Justice Programs, for instance, even if the title of that article didn't necessarily have the term government agencies in the title. So this is, a much more efficient way of searching, and also a way of finding papers related to what I'm looking for that might be hard to find otherwise. So again, there are risks here. There are big concerns around, are we losing our ability if we rely on this kind of technology to scour the literature and find what we're actually looking for? There are concerns around, is this just bringing up popular papers as opposed to the most relevant papers? There are concerns around other kinds of biases, for instance, gender biases, that are often reflected in the outputs of AI, since it's trained on data that reflects human preferences and biases. Well, another risk here is that, unfortunately, a lot of these AI tools, instead of simply saying, look, this is a better way to search, and giving you a list of search results, they really lean into the AI aspect of it. And the pitch is that the AI will use this list of search results to write an article for you on the spot on the topic that you're interested in. That, I think, is very problematic. There have been a whole bunch of these quote-unquote deep research tools that have been released. The useful way to look at them, in my view, is that they are an interesting alternative to search engines that do better in many cases. The dangerous way to look at them is as a replacement for doing the actual scientific work that goes into writing a report on a particular topic. They mimic the appearance of an authoritative report, but they're not actually authoritative because it's AI. It can make lots of errors. And it's not clear that fact-checking the output of an AI report is any easier than writing the report yourself in the first place. So what I would recommend is that we use these technologies to augment our existing practices as opposed to replace them, and not use them as a crutch. So semantic search is a good way to find papers that I might not otherwise have found, but I wouldn't say it's a way to replace the way we might want to find papers in the first place. Okay, so let me quickly go through some other uses of AI in research, kind of low-hanging fruit, but then also tell you a couple of directions I'm skeptical of, and then I look forward to the fireside chat and welcome discussion. So AI for learning, when ChatGPT was first released, I thought this is definitely something I'm not going to use it for because it can quote unquote hallucinate, make mistakes. But when I started using it, I was pleasantly surprised. I found that it allows me to do some things that I can't do by learning from books. I mean, I haven't stopped learning from books, but I can't ask a book a question. I can't summarize my knowledge of a topic to a book and ask it if I've gotten anything wrong. Those are things I can do with AI. And actually knowing that AI might lie sometimes puts me in a very skeptical frame of mind, which is very conducive to effective learning, I've found. So when learning new topics, I often use AI as one tool among many. It's very useful for exploring papers in new areas where I might not understand the vocabulary or terminology. Sometimes when I have a research idea, I ask AI for feedback. What are some ways that this might not work or might go wrong? I use it to look for connections in other disciplines because it very often turns out, because of how siloed academia is, that different disciplines are talking about the same concept but using different terms. And using AI turns out to be a very effective way of finding the same concept across different literatures, even if different terms are used. And more generally, putting all this together, you can kind of think of AI as a thinking partner. I say this not to hype it up, but to suggest that there can be ways of, metaphors that we can use that can help us design productive ways of using AI to enhance our creativity. It's certainly not a replacement for another scientist who you might have as a collaboration partner, but given that it's always there and can very quickly give responses, feedback to ideas, for instance, it actually, I've found, augments creativity in very useful ways. Okay, so two big things that there is a lot of hype around that I'm actually very skeptical of. So the first one is that AI can now generate research ideas. Well, that's certainly true. It's a statistical text generator, so it can generate things that look like ideas. Some of them might be good ideas, no doubt. But the reason I don't think this is really a big deal is that in every research field that I've been involved in, generating new ideas is not the bottleneck to progress. Executing those ideas takes, orders of magnitude more time than generating the ideas. So usually there's somewhere between 10x to 100x the amount of ideas floating around as the amount that we have actually time to explore and execute on. So generating even more ideas, I don't think, is going to fundamentally help. There's also a hype around automatically making new scientific discoveries. There have been many major claims on this, including by major companies like Google, that have actually proven to be flawed claims, including prominent claims published in the Nature journal. Happy to share references to those papers and rebuttals later on. But my point here is not even that some of these claims have proven to be incorrect, but more that what are we even doing? So I think automatically producing new scientific findings is kind of missing the point of science in many cases, because human understanding is the point. When you arrive at a finding through the process of human discovery, the deep understanding of that topic that it creates in the minds of the researchers actually has a value that far exceeds, in my view, the instrumental value of the finding itself. So if you take that shortcut and get to the finding without the understanding, you're losing something essential about science that will really limit your applicability, your ability to apply that finding, for instance, to a new scenario. And you might find that since you have not built up the understanding of what that finding actually means, you are left flummoxed and limited in your ability to actually make use of the finding. So one way to put this is you can think of science as happening in three stages. At the bottom stage is findings produced in individual papers. And of course, we know that science is not just a collection of facts and findings, it's also theories that help us organize a collection of findings in an area. It's also paradigms that tell us which questions are even worth pursuing in a particular scientific field. So my worry is that AI is already being used in many ways to accelerate the production of findings, and people are mistaking the increase in production with an increase in the rate of scientific progress. And those two are very, very different. And an increase in the rate of production at the bottom level can actually impede the rate of progress in the levels above it. So there's a famous maxim that all models are wrong, but some models are useful. So when we use AI to produce new scientific findings, the truth of those findings is in some sense contingent on the particular model that we have chosen as a way to represent the world in order to create that finding using AI. The task of knowing when is a particular model a sufficiently good representation of reality that we can rely on this finding in a particular context? That, at least as of now, remains an essentially human activity that takes place on the planes that are above the level of individual findings. And what we're doing by accelerating the production of findings is we're actually making it, I think, harder to put enough effort into those essential activities that need to take place. There's a great historical analogy to this. Before the discovery of the heliocentric model of the universe, back when people thought the Earth was the center of the universe, what they wanted to do was predict the apparent motion of planets and everything else in the sky. And the way they managed to do that, even though they thought everything went around the Earth, so that was not a very good predictive model, is they through this concept of epicycles, through the idea that planetary orbits are actually circles that are themselves orbiting other circles. Do folks know about this? The reason I find this epicycles thing so fascinating and so useful in thinking about AI today was this is precisely the kind of thing that AI is good at. It's good at building really elaborate predictive models of the world that give really good empirical results when we test it through methods that are equivalent of predicting the motions of planets, but it has done so not by arriving at the true causal understanding of the world, but instead by providing pattern matching abilities that allow us to match what is in the data and to extend that out into the future. So the ability to use these epicycles to actually very accurately predict the motion of planets inhibited the ability of the scientific community to move beyond the Earth-centric model of the universe, because what they had was working really well, right? And in fact, it worked so well that even today, modern planetaria, for their projectors, use the epicycle model to be able to draw planetary motions on the screen, because again, it works really, really well. And my worry is that this is what we're doing with AI. We're evaluating AI and AI findings based on how accurately it can predict things, but we have no way to understand whether we're making progress in terms of understanding the true causal phenomena behind the things we're predicting. So that is the big danger that I wanted to point out. And so finally, let me end by saying that while there is a lot of low-hanging fruit, all of those uses of AI do come with risks. And to take advantage of AI in a responsible way and to change scientific practices that can enable us to do that, it's going to be a slow and painful process. It's going to take years to decades. That is work that we need to start now. And I think it has profound implications for doctoral training, because it's not as if AI development is going to stop today, and it's going to keep continuing. And so how do we train people for a world in which scientific practices will have to keep evolving year after year? I don't have the answers to those questions, and I look forward to exploring them and other questions in the conversation. Thank you so much.
All right, good afternoon, everyone, and thank you for coming. Move this down a little bit more um, to this wonderful presentation and fireside chat on AI research and education. Arvind's wonderful presentation. I'm delighted to be on stage with you this afternoon to talk about this topic. And I was sharing with Arvind earlier, I was at a meeting in Chicago last week, and there was a session on AI. And one of the slides came across at this session, and it was talking about some of Arvind's work. And so it's clear that his work on AI research and innovation is having a huge impact, not only on this campus with respect to educating our students, but more broadly as well. So again, very much looking forward to the conversation. Perhaps I'll start off with maybe just two general questions that have been on my mind, not exactly connected to the presentation, but about AI. I feel like always there's new technology that comes about, and there's a lot of hype about it. And it's like, well, this technology is going to revolutionize something. It's going to change the way we think. It's going to change the way we educate. It's going to change the way we work. And perhaps I thought that way about AI for some time, but I'm starting to change my mind a little bit. And I'm just curious, in your mind, why is AI different as a technology? Why are we certain that it really is going to have the impact that people are saying?
Sure. Is that too loud? Should I? Okay, sounds good. Sorry, it's a little weird to hear myself over the mic. Maybe AI is not different. Sayaj, my co-author, and I actually have a paper coming out in a couple of weeks called AI as Normal Technology, where we say that the patterns of technology adoption that we have seen with past technologies, with significant past technologies like the internet, those patterns are continuing to hold in these early days of AI, and that is what we should expect to see in the future as well, unless we have specific evidence to the contrary and we have some ideas for what metrics we should watch out for to see if AI is going to be truly exceptional. Uh, that said, I think even if AI is not something revolutionary, I think a technology, again, like the internet, right? The internet has ended up as a communication technology that mediates almost all cognitive work. If AI is going to be a computational technology that, in some sense, is going to mediate almost all cognitive work, that is still huge. Again, kind of in the same way that the internet has been huge, and that requires us to really think well ahead of time about what the impacts are going to be. And I think we missed that opportunity in the early days of the internet, frankly. We've been repeatedly surprised, for instance, when social media becomes a thing and we're concerned about harms to teenagers' mental health, for instance, right? Like, why wasn't there a well-funded research program to get ahead of that? We can talk about that in hindsight, but also looking forward, we can try to see what are those things we need to do for AI now so that we're not surprised in the future.
Absolutely. One more general question as well. If you all haven't had an opportunity to read his book, AI Snakeoil, I encourage you to do so. I took a look at this book over the winter break, as well as another book on AI, and I generated a lot of questions and a lot of things I wanted to ask. But one of the phrases that you said just a second ago that really struck a chord to me, that I was always contemplating around AI. You had said AI has common sense, and I think of common sense as being very much a human kind of activity. Humans have common sense. And after reading this book and the other, one of the things that I was struck to learn is that if you are nice to AI, it gives you better answers. At least that's what I've read and heard, which is kind of surprising to me because AI is not human. Perhaps it has common sense, but it's not human. And I've tried it out myself. Well, if I'm nice to Claude or ChatGPT, does it give me a better answer? And in some ways it does. And so does AI have human-like behavior? Does it have morals? Are we sure that we are talking to artificial intelligence?
Sure, thank you. I do want to point out I was careful enough to say AI has a version of common sense.
Yes.
And I do think, it's not just like legalese. I think the distinction is important. When I say common sense, I'm purely referring to behavior. I'm not referring to internals. Right? I think that distinction is very important. I think as a computer scientist, I'm qualified to analyze behavior. So that's what I usually tend to make statements about. There are lots of psychologists and philosophers and others thinking carefully about AI's internals. To what extent is it human-like? To what extent, what does it mean for AI to have morals, et cetera? I'm not making a statement about any of that, right?
Yep.
So all I'm doing is making the simple statement that AI behaves as if it has common sense. And that actually is very helpful. I gave one example, but another example of this would be a lot of the time when AI is used for consequential decision-making, more traditional forms of AI, since they lack any behavior that resembles common sense, lead to a lot of what are called algorithmic absurdities. One of my favorite examples is for a system that was used to determine whether the state should pay for someone to assist with their disability. A social service worker would come out to the person's home and ask them a bunch of questions and fill in a form. One of the questions was, how much pain do you have in your, whatever is the affected part of the body? In one case, the person said 0 because they were an amputee. They were missing their leg. And the person wrote down 0, and they immediately realized there's something absurd here. That's actually going to count against them in terms of their eligibility for the benefit, when in fact it should count for them. And that's an example of an algorithmic absurdity. That's an example of the algorithm that's going to analyze that form, not having the common sense to know that the 0 here actually refers to the fact that the person is an amputee, as opposed to them saying, I don't actually have any issues with pain. But this is something that ChatGPT can figure out when given a form and a transcript of a conversation, for instance. It has enough of a simulation of common sense to know that there is something wrong in the way that this person's attributes have been coded in this form. And we're actually starting a research project to see if we can actually use that to avoid some of these horrible negative outcomes that sometimes happen with traditional forms of AI. So it's in that sense that I'm talking about common sense.
Excellent, thank you. And my last kind of general question before we talk a little bit more about kind of research and doctoral education is how soon will your presentation and this Q&A be obsolete, given how fast that AI is moving? The advice that you're going to give us, how soon is it going to be outdated?
Yeah, that's a great question. AI capabilities are, of course, moving very fast, but I think the way we should think about it is not so much about the specific capabilities, but instead based on parts of the scientific workflow. Those are not going to change on a day-to-day or a year-to-year basis. So, some of the things I was talking about earlier, using AI for modeling the world, yes, we can do it better now, but that's a category that we've had for decades. And I think the ability to use AI to model the world is gradually improving. Or when we look at AI for searching the scientific literature, yes, the application of generative AI to that is new, but we've had search engines and Google Scholar for decades, and they do have double-edged societal implications. There are papers looking at how Google Scholar makes it likely that the papers that we will choose to read and cite on a particular topic are the ones that are already popular, as opposed to the ones that might be most relevant to the question we have at hand, right? So in that sense, when we look at the parts of the scientific process, even if AI capabilities are changing quickly, we have a lot of evidence to draw upon that we can use to think about what might the future hold.
Excellent, great. Now I want to switch and talk a little bit about the last point that you had, AI in the future of doctoral training, which is certainly the topic of interest to all of us here. Perhaps I can start off by asking something more specific. Here at Princeton, we have doctoral training across 4 divisions: the humanities, the social sciences, the natural sciences, and engineering. And perhaps a lot of people are thinking about how AI will impact the natural sciences and engineering, for example. I'm curious, how do you think AI will change our research in the humanities? Have you thought about that at all?
I have, but I'd rather hear from a humanist on that question. What I will say, though, is that it's not a question of how will AI change things, but how do we want to change given that these AI capabilities exist? So I want to emphasize the role of agency there.
Yep.
And it could very much be the case that AI is technically capable of doing something, but we decide that this is an essentially human part of the endeavor of research or the humanities or whatever it is, and that we want to preserve that as a domain of human activity and expertise. And so it's not necessarily for me as an AI researcher to answer that question, but really for the community of humanists, I think, together to figure out normatively how they want the future to be.
And you had mentioned in your presentation that you're not really concerned about ideas. And one of the things that popped into my mind, being in New Jersey and the home of Edison, is that he was famous for saying, in order to have one good idea, you need at least 1,000, if not more. And so I was thinking that, well, maybe there are a lot of ideas out there, but maybe you need a lot more to get to the good ones. And perhaps that is what AI might do in terms of accelerating our ability to get to good ideas quicker. Is that a fair assessment?
I think that's fair. I think the distinction I want to make is AI generating those ideas independently versus AI enhancing human creativity in getting to good ideas faster. I think those are 2 very different ways of using AI, and so far I'm seeing mostly the latter, and I think that's a good thing, and my prediction is that that's going to continue.
Yep. Yep. And this cuts across all of graduate education, not only ideas, but being creative. And I often say, that's perhaps the most important aspect, I would say, in graduate education is to be able to be creative. And my colleague, Sonali, and I co-authored a perspective with several other colleagues on teaching creativity. I'm curious in terms of how do you think AI will, 1, impact our ability to be creative, and then 2, can it be useful in the process of being creative.
Yeah, definitely. So I think the biggest impact, if I can be so bold as to predict, is going to be. Oh, sorry for the feedback. Is going to be simply from the fact that AI can already automate a lot of the mundane things that go into the research workflow and simply frees up more of human time for the more creative parts of research. And again, some of the AI that we're developing for science really focuses on those pain points. But it can also, I think, be more directly used to enhance human creativity. I want to say that creativity is actually more formulaic than we would like to admit. So I think creativity can be greatly enhanced simply by improving human ability to better draw upon the existing repository of published ideas. So some of the things that I was talking about in the presentation, right, by being able to spot connections more quickly to other disciplines where the same idea might have been discussed except with different words, those are exactly the kinds of things that I mean by enhancing human creativity. It's not that AI has to generate ideas out of nowhere, but really improve the interface between a researcher and the vast repository of scientific literature that's out there and that's currently way too big for people to keep track of and manage and digest and so forth.
Absolutely. One of the other things I was thinking about when you were talking about ideas and now this notion of creativity, and you can correct me if I'm wrong, but the other thing I've read about AI is that the databases that it's built off are always 1 to 2 years old. And so I guess maybe one could speculate, well, the ideas are always going to be lagging by 1 or 2 years. And so to be truly creative, to be truly novel, to be truly, path-breaking, there has to be this human component to it because AI is always going to be behind. Is that also a fair assessment of AI and ideas?
So there's two components to this. One is AI behind in terms of its training data, and that's a technical issue that can be addressed, and I think is largely being addressed. It's not necessarily 1 to 2 years behind anymore. It's maybe a few months behind, and I'm not sure to what extent that will remain true in the future. You can certainly have much faster update cycles, especially as the cost of training or retraining these models decreases over time. But the other issue, the bigger issue, and something that's rather inherent to the way that generative AI, at least, is built today, is that the reason that it's so good at predicting the next word in a sentence, and that's where all of its seeming intelligence comes out of, is that it's really good at kind of finding the average of all the text that's on the internet, if you will, right? So it's what it's predicting is what is the average writer on the internet going to say, given the first n words in the sentence. And that is somewhat central to the way that AI is trained today. And that, I think, is the primary reason why AI, in many cases, is not just not creative, but very, very resistant to be creative. And I've tried this many times because I'm very interested in using AI to enhance my own creativity. So I give it the parameters. This is the direction in which I want you to explore new ideas. And obviously, to be creative, you have to, in some way, disagree with the consensus of what is published. And AI just refuses to do that, right? It just keeps coming back towards the median. And this problem is literally called mode collapse in the technical literature. And people are exploring different ways of training AI so that it is more able to explore the extremes, the tails of the distribution, if you will, instead of always reverting to the mean or median or mode or however you want to think about it. To what extent that will work remains to be seen.
Excellent. Personal question: has AI enhanced your creativity?
I mean, I think so. I mean, my whole presentation was based on the idea that I don't want to hype up what someone else has said, so I'm really going to talk about what I'm using on pretty much on a day-to-day basis.
Excellent. Switch past a little bit and talk a little bit about graduate training. So less about research, but about training. And so somewhat very specific question in terms of how can PhD programs adapt their training to prepare students with adequate AI literacy for scholarship and teaching?
Yeah, I was hoping you would know.
That's why I'm on here to get advice from you.
Yeah, I mean, this is something that I would love to discuss with all of you. But again, one thing I'll say, going back to something I said before, is our approach to training has been you learn the set of methods in graduate school and then you're kind of done, right? I feel like that's going to become harder and harder to sustain. So I think training has to be more about not just learning a particular set of methods, but how do you put yourself in a frame of mind that you're able to find a good balance between staying, somewhat close to the cutting edge of the methods and capabilities that are available, but also not getting so distracted by whatever is new and shiny that you're missing the bread and butter of your research.
Yeah. And perhaps the question is, what will we be missing if we don't do it, or can we afford not to somehow incorporate AI into our graduate training if other institutions will? One of the other things I was thinking about, in terms of thinking about my own experience in graduate school, was I think we would all agree, and the students out there as well, is that some part of graduate education is a struggle. You get caught in some particular research area, the code doesn't work, the experiments doesn't work. It's hard to decipher the literature, the scientific article, and part of the journey, part of the process is the struggle. And when I was in graduate school, I didn't have AI to perhaps reduce that barrier of the struggle. And if I think back on my own experience, if I had a tool that could perhaps smooth out that
Yeah,
entire experience,
yeah,
maybe I would have felt good at the time, but
yeah,
in hindsight, perhaps it wouldn't have been truly beneficial for me. And so as we think about the potential of AI, I'm left thinking that it might truly revolutionize graduate education, where that component of it, getting stuck, overcoming obstacles. I often tell students that graduate school is really about a whole bunch of ups and downs, and overcoming challenges, that AI might reduce that.
yeah. This is one of my favorite things to think about. I think about this almost every day, and the way I think about it these days, at least, is I think there are two kinds of struggle. One is good, and the other is just frustration that we can ideally eliminate. The good kind of struggle is just sitting there with another author's ideas and really, focusing on them and trying to decipher them and to build on them, and to try to spot the connections between different ideas and so forth. And if we were to try to automate that using AI, we would be, I think, losing essential skills that not only are graduate students, but at any stage of your career, right? I mean, to me, those struggles that are part of research are something very essential that feel, really painful in that moment, right? When I'm having a 4 hour thinking session where there are no meetings on my calendar and I just want to think about this hard problem. Uh, and I force myself to do that because I know that's good, even if it feels painful in that moment. It's very rewarding in retrospect, and that's what builds my skills. So many professors stop building their skills once they're out of graduate school, right? Because it's easy for them to take the easy way out and have graduate students to do all the hard thinking and only be an advisor and a manager. So that's something we all have to struggle with. Just to what extent do we want to put ourselves through that? And I would recommend that we all continue putting ourselves through that, even if we have the luxury, whether because of AI or because of graduate students, of no longer actually needing to do that in order to do our jobs. And the other kind of struggle is just not knowing what are even the right search terms, the right vocabulary in a new discipline. A lot of my research is interdisciplinary, so this is a big problem for me specifically. It might not be as big a problem for other researchers, but for me, this is a very unproductive kind of struggle. I have not gained anything by spending 3 hours on Google searches that led me down rabbit holes and then realizing that I didn't have the right search terms and I should have been reading something else to begin with, right? And AI can help me take shortcuts through that. And I think that's a good thing. And I think that will free us to have more of our time for the good kind of struggle and frustration.
Absolutely. One of the processes I enjoy with my own graduate students is writing the first paper, for instance. And I often tell my students that, writing is very much a process, and we may go through 1, 2, 3, 4, 5, 6, 7, keep counting, drafts of a manuscript before I think it's ready to be submitted for peer review. But in each one of those iterations, there's learning that happens on both sides. To be fair, are we ever going to get to a point where we're going to receive perfect manuscripts in the first draft and I look at it and say, this is ready to go?
So, two things to say on this. One, I think today's AI sucks at writing. I don't know, in my experience at least, it is so good at producing a thoroughly mediocre, business document, right? Where it's very nicely formatted, very polite, etc. But what you're looking for in scientific writing or in persuasive writing, a lot of my writing is to, the book, for instance, right? The goal really is to be persuasive. You want to convey information, but also persuade someone of a point of view. Again, that's the kind of writing that needs to fundamentally differ from the median writing on the internet, if you will. And so this notion of predicting the next word results in AI that's really bad at the kind of writing that I think is most valuable in our society. That might change in the future. Some aspects of this are issues that can be addressed technically. That said, even if AI could produce, you know, uh, really persuasive manuscripts on a given topic, for instance, should we rely on it? I would argue no, because as you've said, writing is not just an essential process of skill acquisition, but an essential process of what it means to do science. So, not just does the manuscript change through the process of writing, I'm sure in your experience as well as it is mine, the research question often changes through the process of writing because you find out that you've been addressing the wrong research question all along. And to try to automate writing, therefore, would be to lose essential parts of the scientific process, and our work will suffer for it.
Excellent. I had several more questions that I wanted to ask. I've been told now is the time to open it up to the members of the audience.
So we've certainly said the two letters AI an awful lot up here. I didn't catch what your background was when we first started. Was it computer science?
It is.
Okay. So are we, it seems like these conversations are exclusively centered around chat interfaces. Is that how you envision people envisioning AI? Because I'm a software engineer, and when I think of AI, I think of many other use cases, many other types of models, many other types of machine learning and its applicability to the world around us. But this conversation seems to be centered in kind of the chat GPT and the interfaces that are making people think they're texting with a friend, maybe.
Yeah, I mean, believe me, I wish I weren't up here saying the words AI an awful lot. I think so the central theme of our book, and literally the first paragraph, talks about how misleading it is that a diverse collection of somewhat unrelated technologies are all called AI, and we really wish that weren't the case. But there's just a powerful effect to that term of bringing people together in conversations, which I have reluctantly come to accept. We tried to use the word AI much less in our book, but our editor very rightly told us that's not the way to have a successful book. So that said, to answer the second part of your question, yes, there are many types of AI that are relevant in science. A lot of the research that Sayesh and I have done, and the reason we're known for our work in AI and science is because we've looked at more traditional models, ways of using random forest or regression or whatever to model the world, and what happens as those technologies have gone from computer science to various other fields like medicine, political science, social science, etc. And our central conclusion is that these are actually tricky to employ very correctly, and they've very often been employed without the right guardrails in place. And we have a series of papers. The main one is called "The Reproducibility Crisis in Machine Learning-Based Science." We have so that whole thing is based around not chat interfaces. However, this conversation, as I understood it, is about the role of AI in scientific ideas. And there, with the whole notion of enhancing creativity, generating new ideas, all of that, for better or worse, has been focused around the chat interface. And that is how a lot of people are using it for these purposes. And I do think it's worth talking about, but that's not the only piece of AI in science.
In the back there.
Hi, I'm a computer science PhD student doing computer architecture. So there are two things you... Yeah, so there are like two things you spoke about, which is one thing that writing is a very important part of doing research. So I started using ChatGPT 3.5 and now I've gone on to 4.5. And its writing capabilities have changed a lot. So it would like give me... So I was writing a paper Picking out with 3.5, would write something down, put it into 3.5, it would give me like really bad writing I would never use. 4.5, so it's I think trained over the entire Google Scholar, so the writing is excellent, really good. I showed my advisor the draft that GPT created from like I would write what I wanted in a paragraph, put it into GPT, ask it, make this writing scientific. It'll give me something really clean. My advisor was like, solid, right? So things are changing. So what does it then mean to do research? Because you said like writing is super important for grad students. So like, instead of doing 8 drafts, I need 2. And that actually changed for the paper I just submitted. So which was really great because as somebody who's not from an English speaking country, it also lowers the barriers for us. And the second part is, I'm a fifth year now, so I'm graduating soon. The hardest part for my PhD was finding ideas. Right? There are ideas a dime in a dozen, but good ideas are very few. In architecture, we improve chips. So I work on making better CPUs and GPUs. So you stand on the shoulders of giants. You read a lot of prior works. I had to read 100 papers to come up with like one idea. And the whole process is you see what the trend was across these papers. But now with GPT, right, the barrier again has reduced so much. GPT can read 100 papers for me. Let's say I want to improve caches. Go read all the cache papers. What is the problem? Tell me the answer. So now, what does it mean to do a PhD? Like, do you have a different delta now that you want from like graduate students for ideas to go into their dissertations? Uh, like it is really confusing me. Like, what is the value that I'm and this is AI today, and it's changed in my like when I entered grad school, there was no like GPUs weren't everywhere. Now I had just have job offers because everybody wants a GPU, right? This happened in 5 years. So what happens 5 more years down the line? I think both of these are very hard
Do you
to
want to take a
You
crack at
think
this?
these are for me?
No,
Yes.
no. I mean, for
Um,
both of us.
I mean,
Yeah, go
thanks
for it.
for asking that question. As educators and administrators, we are asking this question every day. So it's great to hear that from a student coming in or like a PhD candidate coming.
that's a very intriguing question for sure, and one that has a very long-winded answer. But I'm going to try and be very brief because I don't think the full answer is accurately fleshed out by anyone at this point. But perhaps it was hinting at my question about the experience in graduate school and my experience in particular, struggling with ideas, struggling with writing, struggling with digesting and synthesizing information because one view of graduate education, it is a moment in time where you can think very broad and very expansive about a particular area, but that does require you to participate in it um, without a tremendous amount of assistance, in my opinion. Um, and with AI, it changes that, as you were alluding to. And so then you do have to ask the question, are our students acquiring the skills that we believe they are acquiring with the PhD? If you, for instance, don't go through the process of generating ideas, there's one thing to come up with a whole bunch of ideas, but if you say, well, where do good ideas come from? To me, good ideas come from the process of graduate education. It comes from the process of reading the literature. It comes from the process of going to conferences and hearing presentations. It comes from the process of going to the seminars and research conferences and presenting your work and having to stand up and answer questions on your work. It comes from the process of going to the coffee hours and engaging in dialogue with your peers on ideas, from the process of participating in class. And if you can shorten that process in some way, I think it does diminish the value of doctoral education because you do want to go through those activities, at least in my opinion. Um, I think it helps with the understanding. I can ask ChatGPT, what are the 10 greatest ideas in my research area? And I may have those, but do I have the understanding behind them? And I think that's what doctoral education would provide. And it's reading the papers that would allow me to come up with those ideas, gives me the understanding and the context behind them. I would say the true expertise that I think doctoral education provides. It also may be in this moment in time, look, if ChatGPT can give you a million ideas, can we help as experts identify which are the good ones? That may be something we need to be thinking about as well. So I think it's really about the experience that's going to be really important. I think it's about the fundamental understanding that's going to be really important as well. And it may change how we think about some of our evaluations. I think you made a really good point about writing. Um, it helps lower the barrier to writing for non-native speakers, which is really important. But it might then mean that oral communication becomes more important, not only in the ability to communicate science, because science isn't done unless it's communicated either in written or oral form, but then also perhaps in the skills that employers will be looking for in the future. Not so much, well, can you write well and communicate well? Because, well, everyone can do that now in the world of AI, but can you tell a story about your research? Can you give the elevator pitch? Can you do it at a whim, for instance? I think. So that's my kind of initial kind of response to your question that I think is a really good one, and certainly one, folks are thinking about, because we do value the experiences that our students go through, recognizing that they are likely going to be changing very rapidly, not only with respect to STEM research, as you alluded to. One of the questions that I had asked was about the humanities, because the hypothetical I had given to colleagues was about graduate work in the humanities, and whether or not, if you use AI to summarize literature versus reading all of these books, are the students getting the training that we hope they are receiving? I don't know if there's anything you want to add to that.
Yeah, that's great. Yeah, thank you.
Yes. And then we'll come.
Hi, is this on? Okay, here we go. Hi, I'm Rose Ginrich, and I'm a fourth year in psychology, and I study human AI interaction from the perspective of psychology. And Arvind, I love your work. Really, I love following it. And I have a comment that I'd love to hear your perspective on. So when Dean Priestley asked you, is AI different from other technologies? Your response was, maybe, maybe not. And my question from a different lens is, maybe AI is different from other technologies in that it's human-like, or at least appears human-like, in terms of its external characteristics, like having a name or maybe having an avatar, but in its internal characteristics by possessing the capability of reproducing language. And in my research, what I see is that because it's human-like, people tend to trust it more or be more persuaded by it. For example, when it provides writing or some sort of other, generative content, people are more likely to trust it or take it at face value and be less critical with it. So I'm really curious your perspective on that aspect of AI.
Thank you. Appreciate that. Yes, AI is human-like in some ways, or at least simulates human-like behavior in our user interaction with it, which is certainly different from other technologies. This is helpful in some ways. It allows us to better anticipate, for example, the fact that sometimes when you're more polite to it, you get better results. So it's instrumentally useful, but it's also deeply misleading in other ways. So in my talk, for instance, I was talking about how, because these are formatted as scientific reports that an authoritative author might write, you're misled into thinking that the same kind of work has gone into it, whereas in fact it has not. There are, I think, two ways we can change things so that things are more clear to users. One is by pressuring companies to do a better job of making clear in the user interface what is going on. And there has been a lot of external criticism along those lines. Companies have been kind of marginally responsive to it, not nearly as much as they could be. I think we should continue putting pressure on them. And the other, this is something we can learn. I mean, the first time we saw ChatGPT, of course, it was the simulation of human behavior, and we were wowed by it. We didn't know what to think. We were confused, etc. I mean, it's been a couple of years, right? We can train ourselves to really understand what's going on behind the scenes. In particular, I think it's super critical for young kids, starting from early ages, to understand what's going on behind the screen. I use AI quite a lot with my two kids, 5 and 3. both because it's fun and it's really good at telling stories. For instance, after the 20th time I've had to tell a story in the course of an hour, I did not have any more stories in me. But with ChatGPT, you can give it a particular topic. Anyway, you know what I'm talking about. But also, another important reason why I use AI with them, because I think that's actually the right age for them to start understanding what AI is. And we have frequent conversations, including one just last night, where my son was like, "I think ChatGPT is a person," and we had a conversation about what that means. So, yeah, if we start with kids, I think we can do a better job of educating users to have the right kind of relationship and interaction.
Thank you for your talk. My name is Emilio. I am a third-year PhD student in comparative literature, so I'm representing the humanities here. Last year, Eric Schmidt of Google, he gave a talk on where the real impact is going to be with AI is on agents. And so my question revolves around the integration of agents with robotics. Is it the case that, say, 10 years from now, there will be more AI robots than there are humans on the planet? And if that is the case, then how is this going to impact national economies, but also defense, national defense programs?
Yeah, thank you. So there are lots of AI robots already out there. Some of them are in warehouses. Self-driving cars are examples of AI robots. So this is a technology that has been gradually improving for a long time. I think the recent excitement is around combining large language models with traditional robotics and going back to the issue of common sense. So the idea that a large language model has built into it a vast amount of knowledge about what various household objects are, and so you can integrate that with a robot. And if you say, go pick up that towel, it'll know what a towel is without you having to explicitly program it in. And so the hope is that this is going to lead to rapid improvements in the variety and usefulness of physical robots that you can have. So my tentative prediction on this is maybe, but what I think a lot of very optimistic predictions miss is that there is a big gap between building some capability and getting enough reliability out of it that you can make it into a product, mass produce it, and for people to actually trust it and use it safely. That's what happened with self-driving cars. That's why there has been so much hype about it over the last decade, with CEOs consistently predicting that it was only 2 years away. 2 decades ago, there were successful demonstrations of self-driving cars. So we had the capability back then. But to push the reliability up from 90% to 99% to 5 nines of reliability, each of those took a very slow feedback loop of putting those cars out there on the road, getting enough driving miles behind them, getting that data, using that to train the algorithms to get another 9 of reliability, right? So that's one way to think about why that evolution has been very, very slow. And obviously high reliability matters, particularly with physical robots. And so that's my sense that even if there are going to be rapid capability improvements in some sense, the actual deployment of these is going to happen on a relatively slow timescale that we're used to with other kinds of technologies, and which is different from ChatGPT being unleashed on the world overnight.
I can do the closing question if that's okay.
I had one more too, but
All
go ahead.
right, go ahead.
No, go ahead.
I'm kind of cheating because I've heard Arvind say this before. You had said that your aspiration from AI was that it would increase interdisciplinary collaboration, but you're not seeing that, at least in your experience and your surroundings. How can we use AI, I guess, to increase more humanists working with scientists and engineers and like really cross-disciplinary, transdisciplinary work, scaling that up or increasing the rate of doing that?
Yeah, thank you. So reflecting on my own experiences working with people from other disciplines, they have been among the most exciting and productive, but also the most frustrating in some ways. And it's a good frustration because you have to learn a whole different culture, a whole different way of thinking about the same problems. You have to learn a different language, people using very different terms for the same things and using them in slightly different ways, etc. And only after you cross those barriers do you even get to the substance of the collaboration, right? And so, that's where I see a lot of potential ways to use AI to to bridge those gaps more easily. I've already found that in my own work, it's allowing me to get into new bodies of literature much more easily than I would have been able to before. And the next step is going from there to actually building relationships with people in those disciplines that I'm drawing upon in my own work. So I guess I would say that maybe I've already changed my answer a little bit from the previous time we talked about it. I am starting to see that, and my hope is that it will accelerate in the future.
Last one. Last question. I guess you started off the presentation, if I recall, that saying, well, people may predict there's going to be 1 billion geniuses or 1 billion experts, and then you ended the presentation with, AI will impact doctoral education. And then there was a question here in the back about, well, now, what is the value of doctoral education if AI, in this world of AI, for instance? And I was thinking about that, and one of the quotes I like to say about how do you identify an expert or a genius comes from one of our famous Princeton grad alum, Richard Feynman, in physics, who went on to win the Nobel Prize in Physics, and he was known for saying, how can you spot a genius or expert? And it was based on kind of like the 3-question rule. You ask them a question once, they'll have the answer. If you probe a little bit deeper, an expert will have the answer to that second question as well. But then if you go a third level and then probe, an expert will not have the answer, and they'll be able to understand why they don't have the answer. And the person who does have the answer is the bullshitter, using your language as well, as Feynman alluded to. And so, when we think about the value of doctoral education and in the world of AI, is it that we're going to create people who have access to a lot of facts, or there'll be people who have access to a lot of facts, but they're not necessarily going to be experts because they're not going to have the underlying knowledge and the underlying expertise that doctoral education provides.
Yeah, that's a fantastic note to end on. I'll just reflect on my experiences. I learned quickly being a faculty member and training graduate students, especially in a field like computer science, where the programming skills required for research are already mastered by undergrads who are coming into graduate programs, that teaching them to solve problems is the easy part. A lot of them, in fact, already come in knowing that. But teaching them to develop judgment and taste on which questions are worth asking, intuition on which directions are more likely to lead to not just success in terms of internal metrics of research, but external change in the world on a 5 to 10 year timescale, right? That's a much more difficult task. And in a world where more and more of the actual problem solving is going to be automated, maybe those will become even more important.
Excellent. Thank you. With that, I ask you all please to join me in thanking Arvind again for this wonderful talk. And I remind you all that we do have a copy of his book in the back. Make sure you get a sign before you leave. Thank you all for attending.